2013, Professor Mark Post introduced many of us to the concept of cultivated meat via the introduction of a rather pricey burger at a press conference in London. 10 years later, I'm delighted to say we've got him here at AgFunderNews to talk about the progress that's been made in the industry since. So we're going to get into the weeds on everything from cell lines to bioreactor size to scaffolding and so on. And we're also going to talk about funding and the commercial viability of this technology. So I am delighted to say he is waiting in the wings, so I'm going to bring him on screen now. Hi, Dr. Post. Thank you for joining us.
Hi. Well, thanks for having me.
Excellent, thank you. So I guess 10 years ago when you unveiled your cell-cultured burger, the press coverage around cultivated meat was almost universally positive, whereas today, 10 years on, we're seeing more skepticism. Would you say that there's just a kind of dawning realization that Rome wasn't built in a day, or are there still serious questions about the commercial viability of this technology?
No, I think it's more the former. Back in that time, I said it's going to take 10 years to commercialize, and a lot of people said, "Okay, no, in 2 years, this will be ready."
Yes.
But I realized that that was not the case. This is still a pretty big task, and especially to scale up and to make it cost effective and to get regulatory approval. So there are a lot of hurdles. None of them which are unsurmountable, but together they just delay. The cost, and this has been somewhat debated, but let's say it's 50% consumables, 50% ingredients, 25% labor, and 25% building and bioreactors, right? So yes, you can, if you increase the cell density, you reduce the component of the bioreactors because you use your bioreactors more efficiently. But it's only 25% of the cost. If you reduce the amount of medium that you need or an amount of consumables to make that kilo of meat, that's where you have the big gain. And this happens through, for instance, a continuous process or feeding strategies and not complete replacement of medium recycling, perhaps, and getting cheaper and cheaper ingredients in the medium. So get the cost of the medium down from what was originally €200 per liter to eventually something like 20 cents per liter.
Have you seen some interesting developments when it comes to technologies or things like small molecules that can speed up the differentiation process?
Well, the differentiation process for sure. There is a company called Profuse in Israel. They have developed a cocktail of small molecules that make the differentiation process for muscle a lot more efficient. We have a similar thing for fat cells. And so, yes, there are some developments there, and they're actually major. We go from 50% of our cells differentiating into muscle to 95%.
Right.
So those are major improvements, and the same in the fat cell region. For medium components, for replacement of serum in the medium, we see a similar trend, but it's going somewhat slower.
So, I mean, what would you say has been achieved over the past 10 years? Are there some areas where you feel more progress perhaps has been made than expected, and maybe others where it's been slower to materialize?
Yeah, sure. So back then, the hamburger was still made, or the cells were still cultured with serum. All the companies now got rid of that, almost all of them. So this is no longer an issue, which is a major advantage. And that was not predictable at that time, but it turned out that way. What definitely was not predictable, that it amassed so much enthusiasm all over the world. So now with 150 or an ever-growing number of companies doing this in all sorts of different directions, different species, supportive activities. So that is one of the most amazing things, that it developed in such a company type of and multi-person type of activity, and that of course guarantees that, or at least makes it possible that events go faster, that advances go faster, because just more people are working on it.
I mean, but perhaps with cell culture media, what gives you the confidence that costs will come down sufficiently that this is something that can be produced in the millions of ton scale?
Yeah, mostly because a lot of third parties, and those are the people who make the recombinant proteins that we need to replace the serum, are scaling up and competing with each other, so that the ridiculous prices that we had in the beginning
Yes.
have come down tremendously. And the same is happening at the basic ingredients of the medium, where pharma grade materials gradually are being replaced by food grade materials, thanks to the help of some of the food companies and suppliers.
I mean, when it comes to the pricey growth factors, I mean, I've seen companies who produce them in fruit flies. I've seen some companies making them in barley, off genetics in Iceland. Some companies, using microbial fermentation and so on. What do you see as the most are you seeing some promising developments there?
Well, they're all. I think they're all promising in a sense. What is difficult to predict, especially for me, who is not in that particular field, is how can you drive that cost down, which is mostly in the purification. So if you have a product from barley that doesn't require the same amount of purification than if you have a product that comes out of bacteria, then barley eventually will be a winner.
Yes.
But I'm not an expert in this. I just now get acquainted with kind of the regulatory repercussions of this, and so it could be that expression systems that are more food compatible than bacteria or yeast eventually kind of win this game.
So when it comes to cell lines, some companies that we've spoken to are using embryonic stem cells or induced pluripotent stem cells. And I understand you're using adult stem cells, sort of fat and muscle precursor cells, if you like, and then sort of going back to the animal once they stop dividing. So you're not kind of meddling with them to immortalize them in some way. Can you talk a bit about why you've chosen those cell lines?
Well, mostly because a lot of those immortalization strategies require genetic modification. And that's what we try to stay away from. Since we are in a European market, consumers in Europe are not really accepting genetic modification in their food. And I use genetic modification as a very broad term. There are finesses, and so eventually this may change. But currently, all the genetic interventions in cells are, according to European law, genetic modification. They fall under one category, at least in animal cells for now. And that means that the advantage of using primary cells is that you don't have to do that. The disadvantage, of course, is that you once in a while have to go back to the animal to get new material. That, in our minds, and we have discussed this with many, many people, is a rather innocuous procedure that is acceptable, especially if you limit that tremendously to the number of cows that you will need for this process.
So I want to talk about this issue about what is meat.
Specifically, there are probably two components for the meat. One is heme iron. Meat is a good source of heme iron. Heme iron is a good source of iron. And if you don't differentiate, you don't have heme iron. That's the end of it. For the muscle proteins, we're looking at a specific amino acid composition and an amino acid profile that happens to be a complete amino acid profile for us. If you just make cells which, let's say, make collagen, which is a very boring and uniform amino acid profile and poor amino acid profile, then you make essentially a very different tissue that seems to be meat, and but it's from an amino acid profile point of view completely different.
So, I mean, some companies seem to be harvesting kind of cell biomass, adding some plant proteins to make sort of hybrid processed meat products. Others tell me that they feel to make something that's really like meat, you need a sort of second phase where the cells differentiate and mature into recognizable tissue and so on. What is your approach?
We are the latter. So we feel for nutritional value, very specific nutritional value of meat proteins and fatty acids. And for fatty acids, it's more the taste profile, so that you don't need to cover up things and need to fabricate a taste that's originally not there. We feel that we have to make tissues that are as close to the original as possible. For that reason, now, for future development into whole cuts, it for sure is necessary, because otherwise it will not really look like a steak. Very similar to the problems that we have now with plant-based texturized material that is transformed into a steak, where if you squish it, it's quite clear it's not.
But there's a difference between just getting cells to, I guess, differentiate versus actually creating sort of fibers and so on. I mean, is there a stage whereby you can just get the cells to differentiate, but you're not necessarily going down that full kind of tissue production approach?
Not really. For fat cells, for sure.
Yeah.
Right? Fat cells make a rather loose tissue, and they're not really dependent on each other that much to form a tissue. So for fat, that's fine.
Yeah.
For muscle, it's not. Muscle cells need to merge into a fiber, and they need to have anchor points when they start to contract, they have a tension that drives really the production of muscle proteins as we know them. So for muscle, to create that in some sort of amorphous tissue, give differentiation signals, but not the environment to differentiate, will just not be sufficient.
So how are you actually then achieving that if you want to create something that's more like muscle tissue? Are you using some kind of alginate or?
Yeah, we put them in a gel, and the gel is very specific so that the cells can actually interact with the gel and contract it. Gel is 99% water. So if the cells are swimming in that water, they cannot find each other. But if they can interact with the gel structure and compact it, they can find each other, start to merge, and start to align if you put them in the right kind of configuration. And they start to align and they start to contract. And that's where, if they have the anchor points, start to produce the muscle proteins.
So what happens to that gel at the end of the process? Do you separate that from the final tissue at the end? And is that an expensive or challenging process?
No, it's part of the final product. That's kind of inevitable, but it's a very minute part of the final product, because again, it's 99% water. That water is squeezed out, and you are left with the little threads of alginate in between the muscle fibers.
So I want to ask about this issue of processed products, the first wave of products, versus sort of whole cuts, steaks, and so on. Is the technology to produce whole cuts, and I've seen, various efforts around scaffolding and 3D printing and other technologies, is that stuff ready for prime time yet? Is that scalable?
Not yet. And I think there are two sort of distinctive technologies. One is to make small pieces and glue them together with transglutaminase, as we are doing with scrap meat nowadays as well. That obviously is doable, but it's not really desirable. To construct, let's say, a ribeye steak where you have fat in it and muscle and texture and a channel and perfusion system to keep everything alive, and especially the last one is more difficult to scale up than just having cells in a bioreactor. That technology is not ready yet, and especially not at a cost-effective level.
So when it comes to the commercial viability of this technology, we're seeing the first wave of products that are likely to be hybrid products combining some level of cell-cultured meat with sort of plant proteins and other products. Is that your initial approach to do a sort of a hybrid product? And how much cell cultured meat do you need, in a ratio to make a convincingly meaty product?
Right. Here again, we make kind of a distinction between muscle and fat.
Yes.
Because we grow them separately and we grow them both. So we are looking at how much muscle do we actually need to incorporate into the product, and how much fat. For fat, it's very, very little. We find that a very small percentage, actually much smaller than you typically find in a hamburger, is enough to turn a plant-based kind of run-of-the-mill plant-based hamburger into a animal plant-based hamburger, if you like. And it's surprisingly little how much you need. For muscle, it's a little bit different because that adds less to the taste and less to the cooking behavior and more to the texture. And we have started with small contributions, and also there it's kind of surprising that you need relatively little contribution, but for sure it's going to be more than fat, because that's, and the percentages are really small. Yes, we are thinking about a hybrid product, as everybody, and that's necessary just because of the initial market, the initial production capacity, and to get to some level of marketing and some level of price effectiveness. So while gradually we are diluting the amount of plant-based protein in that hamburger.
Okay, so I want to talk about bioreactors because, again, different companies we've interviewed, some people say they're using fixed bed bioreactors, others are using bioreactors that operate on a continuous process. Some say we can do this with 1,000-litre bioreactors and make money, and others say we'll need 1,000,000 litres, and so on, with all the challenges around that. Do you feel that there's a sweet spot? Do we know what that is yet? And what do you do at Mosa Meat?
Yeah, we don't know what that sweet spot is yet.
Yeah.
You have to balance the output of or the efficiency of the bioreactor and the efficiency of the labor. One clear thing is, if you operate a 50,000-liter bioreactor, it takes as much labor as if you operate a 10,000-liter bioreactor. So it's quite clear that with economy of scale, through reduction of labor, you can economize. However, large bioreactors, when they got infected, you run a big risk. So that's, I guess, where we have to find the sweet spot with making sure that we get the efficiency, we get the economy of scale, but not the sort of risk of when a contamination occurs that you lose the production of, let's say, a month.
Yes. So you've just opened a scale-up plant in Maastricht. What size bioreactors do you operate there?
There we operate 1,000-liter bioreactors.
Yes. Yeah.
And that's just because we are starting up that scale-up procedure. This is not our end game, for sure. But again, it's kind of a little bit seeking where the end game will be. And this is also a game of scaling up with the funding and scaling up with the market and with the regulatory approval. You don't want to peak too early. We've seen a couple of examples of companies who have started to build companies and they don't have a market yet, and they don't have approval yet, and then you run into cash trouble.
So what do you see as the biggest technical barriers facing the industry at the moment? I mean, you've said in the past you see a clear path towards price parity with conventional beef. I mean, is that based on assumptions? Is that based on certain assumptions about technologies that haven't been invented yet, or is that with sort of current technologies?
No, it's actually with current technologies, but with implementation. Well, yeah, what is not invented yet? If I replace pharma grade sugar with table sugar, is that an invention, or is that just logic and say, okay, yeah, I can now swap this for exactly the same material, but it's only a fraction of the price. I personally consider that kind of R&D, but not really inventions.
Sure.
So um, all the technologies and the principles are there,
Mm.
but they all need to come together to get to price parity.
When it comes to regulations, how challenging is the situation in the EU?
So you feel some frustration that nobody has applied yet at the EU, and that's of course because the EU has this political kind of form where it takes an extra 9 months to get regulatory approval over all the other geographies. So that's and with that 9 months and with 27 member states having to say something about it, it becomes also more uncertain. The scientific part is exactly the same, and the scientific part probably is is probably the best in the world. We don't know that, but it's because of the preparation and their history. It's probably the best in the world, but the political part makes it just lengthier.
But I'm told by some people that in other jurisdictions that you can have conversations with officials at the relevant regulatory authority to understand in advance exactly what it is that they're looking for, so that when you submit your dossier, you feel that you've got all the information you need in order to make your submission. Whereas people tell me that in the EU, it's not possible just to pick up the phone and have those conversations saying, well, exactly what toxicology studies do I need? Or, you know what I mean? Or is it possible to have those conversations with EFSA, for example?
It's possible to have them with the scientific committee of EFSA. It's not possible to have them with the panels.
Yes.
However, on the flip side is that their documentation of what is required is far more detailed than
Right.
in any other jurisdiction. So,
Mhm.
in the end, if I'm not an expert in this, but if I
Yes.
talk to food companies, they actually like the European system because it's clear and there are no shortcuts, and it's just you know what you are up to.
So is Mosa Meat then planning to submit a dossier to the EU soon? And what are the first markets that you're planning to enter?
For sure, we are a European company.
Mm.
We're set to get regulatory approval in the EU,
Mhm.
and that's going to be sooner rather than later. But of course, we also are, like other companies, are banking on kind of the speed of Singapore and perhaps the speed of the US. So it's a multi-prong approach.
Mhm. So I want to talk about sustainability. A recent UC Davis study that caused a bit of a controversy. It wasn't peer reviewed, and people were saying the assumptions based on it, were out of date and so on. But the headline was greenhouse gas emissions are going to be 25% higher with cultivated meat versus, and then other studies will come out with something completely different. How much do we really know at this stage about the sustainability benefits of cultivated meat?
Yeah, so we have seen life cycle analyses for the last 10 years, and they're all preliminary because you can physically only do this if you have a production system in place and a complete
Yes.
supply chain and transport and so forth. So there are a lot of assumptions, and the value of these studies is that for us companies, we can figure out which levers to pull to make a sustainability impact. And for instance, it's quite clear that last study focused on the cleaning that's required to get rid of LPS. Well, we don't have to get rid of LPS; it's just not necessary. We know that by now. Another study from CE Delft said, okay, if all the energy that you require for this, and there are again a lot of assumptions on how much energy you require, but if you all take it from renewable sources, which to me makes sense, then you do have a major sustainability benefit. So it's still out there, I think, in terms of land use and water use, and it's quite evident, and most LCA studies agree with that would be a saving, which, by the way, is also a big environmental
Yes.
benefit. But on energy, the jury is out there.
Yes, yeah. So I want to talk about money. I understand that you've raised, $100 million sort of plus from backers from Leonardo DiCaprio to
Right.
Nutreco and so on. But does this industry need government funding to get off the ground, given, the reluctance of VC funds to finance large capex projects and, the unwillingness of banks, I guess, to finance tech that hasn't yet been proven at scale?
Right. If you have asked me this question a year and a half ago, I would have said no.
Yes.
Now, now the situation has somewhat changed, and when I look at the discussions about energy transition and other major changes in the industry, where they're really looking at governments to support this, I start to think that we probably would require something like that as well.
Mm-hmm. And I mean, when it comes to financing this industry, there's been a big drop off in food tech funding more generally, in the last sort of 12 to 18 months. We're starting to see companies that are sort of going under and so on. And I guess, all eyes are on some of the companies that have now commercialized this to see what the consumer reaction is. Are you concerned that companies are going to run out of money before this technology has a chance to prove itself?
Not really. And the reason why I'm not concerned is that because we see a lot of involvement of large meat companies like Cargill and Tyson and a number of others, JBS. So when small startups with interesting technology cannot quite make it, I think we will see what we will also have seen in pharma and continue to see in pharma, that they are at some point just acquired by large companies, and that with their capital, they're able to continue it further. The fundamentals of this technology are such that I don't think we can afford, and also the large meat companies can afford to let this dwindle and idle at some point. So I'm not too afraid that will happen, but for sure there will be a interesting and stressful period ahead of us.
So I want to talk about the consumer proposition of cultivated meat. In the US, we've seen that the environmental and animal welfare messaging, hasn't really moved the needle too much for plant-based meat. But there you can at least talk about, the health benefits, for example. What is the messaging around cultivated meat that's going to move the needle for the consumer, especially if these products initially are coming with a premium price tag?
Right. Well, so the messaging really is and should be that that we are replacing meat with meat, and not with a plant-based product.
So it's real meat.
Right. And that I feel has a benefit because we grow up, and especially I think in the US that may be a little bit more pronounced than in Europe. Whereas the environmental impact of livestock agriculture is less emphasized in the US than in Europe. But we grow up with the idea that meat is a wholesome part of our diet. So for a lot of people, and actually the evidence is in the opposite direction, but that doesn't really matter. If the public has this idea, then it will be difficult to transition them to a plant-based diet because they feel that's incomplete and perhaps not healthy enough. On the other hand, there's also obviously a quality aspect to it, and the number of ingredient aspects to it that I don't think that was a major play in kind of the leveling off of plant-based meat products. I think we can set up a whole analysis, and I have my ideas about why that has leveled off. But one of the things that has been underemphasized, I think, is the underlying notion that a lot of people still have, wrong or not,
yes,
that we need meat in our diet.
If you could wave a magic wand and conjure up vast sums of money to support this industry, is there anywhere specifically that you'd really like to see some investment
I would really like to see them in setting up factory systems, setting up factory lines, and working on some of the, when you scale up, some of the equipment is not really tailored for this particular process. So we actually still require, this is especially true, by the way, if you make tissues.
Yes.
If you just make cells and undifferentiated cells, not so much. But if you make tissues, you need specialized equipment to move from the cell production to the tissue production. So this is true for the stuff that we are doing, but it's also, and even more so, true if you want to make a full thickness product.
There was a paper that came out in 2021 by Dave Humbird, which suggested, I think his wording was, that the industry faces intractable problems at food scale. And, you know, I met him most recently at SynBioBetter conference, and he said that he hasn't changed his mind since then, that the emperor's got no clothes. And, you know, this only makes sense when everybody's eating it from a unit economic perspective and so on. Could you speak a little bit to that? Because there are still, you know, some skeptics out there that say, you know, this is really just a food tech fantasy right now.
I mean, some of the points that he makes are good,
Yes.
and we need to really pay attention to them. He does have a pharma perspective, though,
Yes.
and not a food perspective. And I love the current cartoon, not a cartoon, but an image on the web, that if you today would make a chocolate chip cookie with pharma grade procedures, it would cost like $6,000.
Sure.
And so this is essentially what people think we are doing. But of course, we are looking at replacing all these ingredients and also the technologies for something that is cost effective. That this is a big endeavor with some level of uncertainty. Absolutely.
Yes.
Is it so? Is it so kind of unrealistic that you shouldn't even try? Absolutely not.
Well, I think that's probably a great point to end it there. Thank you so much for giving out your time, Dr. Poth. We really appreciate it.
Welcome. Thank you.